So this is lecture number 2, SIG 3006. Yeah. So everybody can hear me, right?
Can
Okay. So in the previous lecture, in lecture number 1, we just recap a little bit on what you've learned in other classes, the basic principles of stratigraphy, and also things like what are unconformities and those kinds of things. So today, you already know what stratigraphy is, right? You've learned about lithostratigraphy, chronostratigraphy, biostratigraphy. So you got the basic concepts in your mind. Today, we want to answer this question. Why do you get different kinds of patterns to the stratigraphy in different outcrops, or in different localities or different basins? Right? What are the factors that control your pattern? What are the factors that control stratigraphy? Okay, so there are actually a lot of different kinds of factors that can affect how your layers are being arranged inside a basin. But I'm going to talk to you about the major factors that influence fascist patterns and stratigraphy within a sedimentary basin field. And you have 3 major factors. Yeah? So first is what we call sediment accommodation. Then you have the nature and the rate of sediment supply. And then you have basin geography. So the 3 major factors are accommodation, sediment supply, and geography. So we go through this one by one. Okay. So let's look at the first factor that influences stratigraphy, and this is what we call accommodation. Right? You've heard the term accommodation. Maybe when you're booking a hotel, right, talk about accommodation, or maybe booking a hall, talk about accommodation. So just basically means the space available, ruang yang boleh tampung orang, ya. So that's we're talking about booking of a hotel room or something. But what about sediment accommodation? So this is the space that is available for sediment to fill. So look at the cartoon on the right hand side here. So let's say you have this is a basin, we call it. Yeah? So you have a depression, right? And it can be filled in. So that is a basin. And this is your substrate. Let's say it's continental crust. Okay. Now this space here is called accommodation. You can fill it with sediment. So it is the space between the ground surface, this is your ground surface, and a hypothetical surface that defines the upper boundary to which sediments will potentially fill. Meaning that you can fill the basin up to here, this point. So that is your accommodation space. Okay, so this is just a cartoon just to show you guys. So you have that basin, and sediment can come through into it, maybe from a flood or something. That's one event, another event, and another event. So it fills in that space only up to that point. So that is your accommodation space. Okay, so let's apply this concept of accommodation to the real world. So if this is ground surface, what is this level here? Well, it depends on your basin. Maybe you're in the sea, maybe you're in a lake. So we call that upper level a different thing. So the upper boundary in an ocean or sea is the sea level. You can only fill in the basin up to sea level, right? In a lake, it's up to the lake level, and so on. All right. Okay, so that's the basic term, accommodation. Right? But you also need to know a few other terms. Okay, talking about sea level now. Okay, the basic definitions and concepts of all these terms related to accommodation space. Another term you need to know is what we call eustatic sea level. Okay, eustatic sea level is the global sea level throughout the world. Okay, and the sea level is uniform. It's measured between the sea surface. Yeah, this is the sea surface. Blue is sea, that's your water, and a fixed datum. So talking about eustatic sea level throughout the whole world, the best fixed datum is the center of the Earth. So you measure the sea level throughout the whole world from the center of the Earth. Okay, so that is your eustatic sea level. Okay, and eustatic sea level can go up and down. Eustatic sea level change, right? So these are global changes in sea level. Okay? And that is because of things like glaciers melting, so you increase the volume of the water inside your oceans, or glaciers are growing, so lots of your water is actually trapped inside ice, so your sea level will fall. So they are actually affected by climate. Okay, or it could be changes in ocean basin, right? Now, if you read the literature, there's also what we call relative sea level. So it's like relative dating again. It's relative depending on your point of view. Okay? So what is meant by relative sea level? It is the depth between the sea surface and a local moving datum. Maybe the basement of a surface within a submarine basin, and so on. Right. So let's say here, if you let's say you are on this side here where there's the red arrow here, right? You are here and you are yes, let's say you are on an island at the top here, right? Now, if you're measuring your sea level using the datum the center of the Earth, so you get the eustatic sea level. But here, if you're measuring from the basement, maybe the continental crust, right? From here, your crust may actually be going up and down. And this is because of tectonics, right? You can have uplift, you can have subsidence. So if you measure it from this local datum, your crust, up to the sea surface, it's not going to be eustatic sea level, it's going to be relative sea level. Okay, and the triggers of relative sea level change is tectonic subsidence or uplift of the basement datum, or even just simple compaction subsidence. So remember compaction of your sediments. So your sediments will sink lower and lower and lower, right? So you get deeper waters here. Right? So, but that is relative sea level rather than eustatic sea level. Okay. And then you have the other term, which is water depth. And this is the depth between the sea surface and sea floor at any given time. So what's the difference? Now here, your reference is no longer the crust here, but the top of your sediment on the sea floor. So maybe after a lot more time, your sediment accumulates up to here. So from here to the surface, that's your water depth. Okay. Another thing to remember, accommodation is analogous to water depth. Okay, so because from here to here, that is the space then that you can actually fill in with sediment. Bawah ni mana diisi dah, ni dah diisi dah, right? So that is water depth is equal to accommodation. Okay, so up to this point, okay, yeah?
Okay, Doctor.
All right. Okay, let's move on. Okay. So accommodation is a function of changes in relative sea or lake level. Okay. But let's ignore lake. We just look at the ocean, at the sea. Okay. From now on, we just use the sea as an example. So we just talk about relative sea level. Okay. Now, eustatic sea level can go up and down because of global factors like climate change and so on. But how does relative sea level change? Right? Changes in relative sea level result from the interaction between the movement of the sea surface, and that is because of eustatic factors, and also the sea floor. If relative sea level changes, the rate of accommodation creation also changes. Okay, and changes in relative sea level can result in things that you've learned already: transgression and regression. You guys have learned about shoreline transgression and regression, eh? Ada kan? So macam apa? If sea level rise, your shoreline moves landward, right? And if sea level fall, your shoreline moves seaward. Okay. Okay. So relative sea level, your sea level goes up and down. It's not static, yeah. But if you follow it through time, it goes down, goes up again, down, and so on. So you get lots of these cycles of up and down. Those are the only directions it can go. Hanya boleh pergi atas bawah je. It cannot, sea level cannot go sideways, right? Okay, so it goes up and down. So you get this sinusoidal pattern. Okay. But sometimes the sea level rise can be very high, and the fall can be very going very low. Okay, so the shape is roughly the same, but things like wavelength, amplitude, and so on of the wave here will be different. Okay, so yeah, you have relative sea level changes in a cyclical pattern. It goes up and down repeatedly, but a single up and down, we call it a single curve. Yeah? It's a complete cycle of sea level fall and rise, and you have two parts of the single cycle. So that you have a falling limb, you go from high sea level to low sea level. It goes down and goes up again. This is the rising limb. Okay, so falling stage of relative sea level. This is relative sea level, high and low, goes down with time. Falling sea level, rising sea level, fall again, and so on. Okay. So how do you get a relative sea level curve, right? Well, the relative sea level curve comes from the combination of two things. So you need to think about the subsidence of the basin. The basin is getting deeper and deeper and deeper because you have compaction, you have tectonics, and so on, right? And then you also have your eustatic sea level curve here. So this is global sea level, and global sea level can go up and down. Yeah. But how you feel it in your location depends also on your basin. Is your basin subsiding very fast? So even though you're having a very big relative sea level, a very big eustatic sea level fall, you don't really feel it because your basin is actually sinking very fast. Okay, so you need to combine both UCC and also subsidence to get the actual relative sea level curve. Okay. So yeah, relative sea level can rise or fall depending on the rate of subsidence. I'll show you how. Okay, I hope this is clear. Yeah. So you have these two curves. Now the top part curve is eustatic sea level rise and fall. Atas ni high or low, so it goes up and down. Now going from left to right, this is time. Okay, time 1, time 2, time 3, and so on. Okay, this is old, this is young, and moving in this direction, time series. So you have another line at the bottom, and this is the rate of subsidence now. So notice that it's going down, it's getting deeper and deeper and deeper for subsidence. Okay, so you need to combine these two to get the relative sea level curve. So let's take, for example, this moment in time going from time 1 to time 4. Okay, so you're going from time 1 to time 4 again. If you look at this eustatic curve, goes up and down, right? Okay, goes up and down tadi. Now let's change this to rise and fall of sea level to rate of change. Okay, you're going from just going up and down, you go to the actual rate. And how do you get the rate? Well, it's just the angle of the slope. That is the rate of change. So if the slope is gentle like this, let's say for 1, the slope is very gentle. So the rate of fall is low. Now for time 5, nampak dia punya slope tu is steeper, right? Lebih curam daripada 1. So the rate is higher now. And so for here, it's steeper compared to time 2, let's say kan. So the rate of rise is much higher sini. Okay, so we've changed this, converted this to rate of change, rate of static change. Now we convert the subsidence plot here, subsidence line here, to rate. So this is what you get. It's just the same amount of sinking everywhere because the slope is the same. Mana ada ubah slope kan? Sama je. Right? So the rate is constant. It's just sinking at a constant rate. Now, if you want to know what happens in your location, the relative sea level, not the global one. Global one might go up, but maybe it's not going up in your part of the world. You need to change this to relative sea level. So you combine both of these, so you get this kind of curve here. Okay. And then you change this back, you change this, make this subsidence line horizontal gitu, and all this moves further upward. This is what you get. Now from time 1 to time 4, the rate of subsidence is much higher compared to the rate of eustatic change. Okay? So what happens is that overall it is rising. You look at the curve, eustatic, it goes up and down. But if you are staying at that part of the world, you don't really see that. Maybe you get some small fluctuations here, but overall from time 1 to time 4, sea level is actually rising, relative sea level, because your basin is subsiding very fast. Okay, so let's look at time 1 and time 3 specifically, khususnya time 1 sini and time 3. Okay, so you get here, you actually see that you get a sea level, eustatic sea level fall, goes down, and also during time 3. Okay? The rate of eustatic fall accelerates, but it is still less than the rate of subsidence. This is much higher, the rate of subsidence. Okay, so you still have sea level rise, relative sea level rise. It's just that at a slower rate. It goes slightly downwards, goes up again, slightly downwards, goes up back again. All right. You can get transgression or regression depending on sediment supply. Well, let's talk about that later. Okay. So here you don't really see any major changes, but let's look at time 5. At time 5, the slope is steeper, much steeper, right? So you get a higher rate of eustatic sea level fall here. So in this case, the rate of subsidence is less than the rate of eustatic fall. So that's much larger compared to this here. Okay, so you actually get a small fall in relative sea level. So it goes down much steeper here. So you get a relative sea level fall. Okay, but still overall it's going up. Okay, a little bit decrease in accommodations here. Sini. Okay, hopefully that was clear. Any questions?
Doctor,
Mm-hmm.
rate of subsidence tu means rates of sediment sinking, kan? Like sediment settle down on this sea
Okay.
level. On the bottom of the sea ke macam mana?
Alright. Rate of subsidence. Okay, probably need to give a definition there. Again, that's a good question. But it's basically it means this. So you have a basin, and originally it was at this position, right? Okay. But then maybe because of tectonics, maybe you have rifting, right? Maybe because of tectonics, maybe because of compaction of the sediment, because more and more sediment is being built up at the top. Right? Water escapes, what happens is that your basin goes deeper and deeper and deeper. It's subsidence. So what happens when this happens, that from here to here, your accommodation space increases. So that is what is called subsidence. Is that clear?
Okay, Doctor. It means that the
Okay.
accommodation jadi more large sebab
Betul.
more sediment sinking.
Yes, it's sinking basically, okay.
Okay.
Okay. All right. Any other questions before we look at the second factor? Okay, saya minum jap. All right. So the second factor that controls stratigraphy, why you get different patterns of arranging of sand and mud or carbonates and so on, is the nature and the rate of sediment supply. And if you want to remember, it's just sediment supply lah. So in some parts of the world, you get a high rate of sediment supply. There's a lot of sediment coming into the basin. You can imagine, let's say, a delta, right? I have a top part here. So here, the rate of sediment supply is very high. Every day, there's going to be a lot of sediment being fed into the sea. But you go to another place, let's say a beach, not much sediment is being deposited. So you have a lower rate of sediment supply. And in some cases, let's say an estuary, a really low rate of sediment supply. Okay, so because of that, you get different ways in which the sediment layers are arranged. You get it is a factor that controls stratigraphy. So better to show an example lah. Okay, after this lah. So with areas with no sediment supply, if there is no sediment supply, there is no pattern, nothing exists, right? So you guys get a stratigraphic hiatus. You can get an unconformity, maybe a paraconformity. For areas with a high sediment supply, your shoreline will move. First it was here, then it was here, because sediment is building up. Ada tanah lagi, macam you tambak lah kan? You're just building up more and more sediment. You're filling it with more land. So your shoreline will move. So that is regression. Now, areas with low sediment supply, you get what is called transgression, where your shoreline actually moves landward. Okay, so not that much sediment coming into the system. What happens is that it becomes eroded, and you get a larger and larger hole here, and more and more embed river mouth. Okay, so you get transgression. So then you can ask the next question, but why does sediment supply change? What controls sediment supply now? Well, a lot of things control it. So, but mainly it's tectonics, mountain building, higher mountains, steeper mountains, resulting in more sediment going down. Climate change. You notice there's a lot of landslides happening right now. One thing is happening, if you look at the data, is that one thing is because of climate change. You have more intense rain coming down in the tropics, so you get more sediment, more sediment being transported down the slopes, and all of this sediment will eventually end up in the sea. Okay, so that is actually controlling sediment supply. And also other things like stream piracy. Rivers are migrating, and sometimes they can join together, and then you have avulsion, right? So it's like just macam tutup pilih lah. You turn off the tap, so no more water is moving into the river, so no more sediment is being transported in that direction. So that's stream piracy. And the third one is geography. You can use this term lah, basin physiography is a more fancy term lah, tapi maksudnya sama, it's just geography. Okay, so how does geography affect stratigraphy? Well, let's say for example you're looking at shelves and planta on continental shelves, and you can have different shapes to the shelf, and the different shapes can actually affect the type of pattern of stratigraphy you get, or maybe the slope that you have, or the width of the shelf. Okay, or maybe you have localized areas where you have more subsidence, or you have uplifted areas. So of course that will affect your accommodation space, and you get different kinds of patterns. Okay, So this is very general. I'm not going to go into too much detail here. All right. So yeah, just to show a picture here. Don't worry. Just the main thing is you remember the major factors that influence these kinds of things, right? So let's say you have this kind of shelf, so a flat shelf at the top, followed by a steep slope. And this one is another kind of thing. This is a ramp, and you've learned about ramps before, carbonate sedimentology, I think. So you don't have a slope; it just goes downwards very gently here, right? So the sedimentology will be different, and of course, the stratigraphy, the pattern, will be very different. Okay, but we'll learn more about that in later lectures. Excuse me. Okay, so just an example, one example here, again, how tectonics affects basin geography and also your stratigraphy. So this is one model for Sarawak. And so you have these faulted blocks, and in the middle here you have an uplifted block. But along the sides you have blocks which are falling down. So this is hanging wall, right? And this is your foot wall, and these are normal faults. It's going down. Extensional tectonics. So notice when you have subsidence on these sides here, you have more accommodation. And what you get are thicker sediments, for one thing. The stratigraphy is already different. And because more accommodation here, rivers are actually flowing into these deeper parts. So you get coarser grained deposits, your fluvial deposits in the subsided parts, rather than here. On this side, you have only thin layers of sediment being deposited. So not much is happening. Okay. So yes, tectonics can affect the pattern of stratigraphy you get in your basin. Let's see how much more I get. I have just a little bit more. Okay. Okay, so those are the major factors that control stratigraphy. So far, okay, yeah? I'm recording this. Hopefully it's clear. Everybody still with me? Boleh dengar?
Boleh, Doktor.
Alright. Okay. So those are the major factors that control stratigraphy. Now, after this, we look at okay. This next session, we just look at how sediment interacts with sea level change and how you get different kinds of patterns to the sedimentary package. Okay, so that's what we're looking now. The stratigraphic response to relative sea level changes. So this is more of an experiment, a thought experiment. So in last year we did sedimentology online, yeah? You guys did it online, right?
Yep.
Okay, so you didn't get the chance to use the flume tank, right? So we have, okay, so now this is more of a thought experiment lah. Experiment kepala kita je. So imagine you have a flume tank. It is a water tank, and the side is transparent. Kita boleh nampak dalam dia. Okay? So this is your basement here at the bottom here, your bed, you see it again at the bottom. And then we fill in the water tank with water. So you have your accommodation space in blue. So let's think about it in terms of sea. So this is your relative sea level, your RSL. Okay. Now, let's say we have a pipe and we can actually pour in sediment into this pipe and going into the flume tank. And lots of different kinds of grain sizes, sand and mud and so on. So let's say we put sea level as up to here, and we pour in, kita masukkan sediment, pour in sediment into the system, and and the sediment we say is sourced from the continents. And let's say we are supplying the sediment into the system at a constant rate. It's always the same amount. Let's say 100 cubic centimeters per hour and so on. And the rate is constant. You don't change that. Okay. So, and the amount of sediment is finite. Ada had dia. Dia kan tak berterusan je ada sediment. Okay. So it can finish. So, let's say sea level is up to time 1 here. So in this case, you put in the sediment and it only reaches up to here. That is your shoreline, get to deeper facies and get some clays going towards the edge of the fume tank. Now, later on, you have a rise in sea level up to time 2, sampai sini pula. And then the rate of sediment coming in is still constant. It's now you get another package at the top, and it is the same volume. Both are the same volume, sama je. Maybe the shape is different, but the volume is the same. Isi padu dia sama. So you get another package at the top. And each of these different packages, they're actually shallowing upwards, right? Go from deeper pro-delta here to delta front to delta plane if you make a sedimentary law. So it's prograding. Okay. So you get these sedimentary packages which are produced because of sea level rise, because there is accommodation space. And these packages we call parasequences. Okay. So what is a parasequence? If you have a basin, and then let's say you have a river, and the rate of sea level rise, relative sea level rise is not really that fast, you can fill it with sediment. And the sediment that fills it in forms a very predictable package. It goes from deeper at the bottom to shallower at the top. And it is what we say progradational, like a delta, right? We've learned about this before, or shore face. And the shoreline is actually moving laterally because of Walter's law. So it's also regressive. So a parasequence is a regressive, shallowing upward succession bounded by flooding surfaces above and below. So you have this shallowing upward succession, offshore, lower shore face, upper shore face, foreshore. So itu dia makin lama makin atas, makin cetek dia punya environment dia. Okay, it's shallowing upwards, the environment. And it is bounded by these sharp surfaces that we call flooding surfaces. Shallow, 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 boom, deep again. Then you can have another parasequence, shallow, 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 boom, deep again. So this sharp change from shallow to deep is called a flooding surface. And it happens because of this. You have this relative sea level rise to here. So now this is going to be a flooding surface. And this boundary here will be another flooding surface if more sediment comes into the system. Okay. So a flooding surface, a parasequence is just a shallowing upward succession. Don't worry about the fascies because different environments, different fascies, but the pattern is still the same. Now, in this case, it's actually finding upwards, but it's still going from deep, shallower, shallowest. And it's a bit separated by flooding surfaces. It's just that this is a tidal flat kind of environment. Okay. So sea level is going up and up and up, but sediment supply in the real world can actually change. Yeah, sometimes it's faster, sometimes it's lower, and so on. So you get different kinds of patterns to it. So here, notice this wedge here. That's a single parasequence. This is another one, 3 and 4. You have 3 parasequences here. Right? So shore face going to transition zone to offshore. So let's say we take this point here, going from shore face to transition as the shoreline from land to sea. Yeah, just to make it simple. Yeah? So you get different kinds of patterns of how your parasequences can stack on top of each other depending on your sediment supply. So if the rate of sediment supply is roughly equal to the rate of relative sea level rise, you get a balance, right? So sea level rise, sediment comes in. Sea level rise, sediment comes in. Sediment comes in, and so on. So it's very static. The shoreline stays just roughly there. Sini je shoreline there. So this is what we call, this is an aggradational set of parasequences. So this is a set. There's more than one parasequence, so we call it a set. So, and it's aggrading. Just stack on top of each other, and the shoreline doesn't change. So this is aggradational parasequence set. Now, if the rate of sediment supply is higher than relative sea level rise, sea level is still rising, naik, arah selalu naik, but it's very slow, and the same amount of sediment is still coming in. So what happens is that this is the same volume, but the space is not, but the accommodation is not the same. So the only direction that the sediment can move is towards the side. Tak ada ruang untuk bergerak dah. Accommodation space kurang. So dia hanya boleh bergerak ke depan ataupun ke tepi. Dia tak boleh mara, dia hanya boleh mara ke depan atau ke tepi je. Okay? So this kind of movement is called regression. Okay? And the pattern of stacking is now called progradation. Shoreline is now moving further and further seaward because there's lesser and lesser accommodation space because of the higher sediment supply. Now, if it is the other way around, sediment supply is much lesser compared to the rate of relative sea level rise. Sea level rise is rising very fast. And still the same amount of sediment coming from during time 1, time 2, time 3. So more space, sediment does not need to travel that far away now. Sampai sini dah cukup dah tak cukup sediment dah, tak boleh nak bergerak dah situ je. So your shoreline moves landward and landward and landward. So you have a shoreline transgression. And the vertical pattern, we call it retrogradational. It's going backwards, so kita panggil dia retro. Okay? So retrogradational parasequence set. This is a parasequence, this is a parasequence, and altogether it's a parasequence set. So the type of parasequence stacking, cara dia bertindih tu, is controlled by interaction between the rate of sediment supply and the rate of sea level rise. Okay, so it's already 8:50. I'm going to end here. Just a little bit more, but this one going to take a little bit of time. I'll just take something like 10 minutes during the first part of the class on Wednesday. We'll start the first practical on Wednesday, but still online. Okay. Any questions before we end?
No from me, Doctor.
All right. All right. So that's it. See you on Wednesday lah. I'll put the recording on Spectrum after this.
All right, Doctor. Thank you.
Thank you, Doctor.
Thank you.
Thank you, Doctor.
Thank you, Doctor.